This training serves as a familiarization to the Garmin avionics system documentation. There will also be some review of basic knowledge in regard to aircraft alterations and associated maintenance documentation. The objectives for the course are simple. We want to help you connect the dots from aircraft type certification to the instructions for continued airworthiness for the Garmin system. We will begin to connect the dots using the definition of airworthy. Although you cannot find the definition of airworthy in any one place in the regulations, there is an industry standard definition that is rooted in the regulations. In order to be airworthy, an aircraft must be in a condition for safe flight and must conform to the aircraft type design or properly altered condition. In 1966, Bell Helicopter certified the Bell 206A. The type certificate number was H2SW. The type certificate has since been amended to include the Bell 206L series and the Bell 407 helicopters. Information about the type design is located in the type certificate data sheet. Very basic airworthiness information is included in the TCDS and is the basis for an airworthy aircraft. When Bell Helicopter certified the Bell 206 and 407 helicopter, they submitted all the drawings, testing results, and documentation to the FAA, and type certificate H2SW was issued. The information submitted to the FAA is the very same information that must be adhered to in order for the helicopter to remain airworthy. Because Bell offers the helicopters for sale, they will not and are not required to give operators all the proprietary information from the certification package, but instead produce maintenance information to be distributed to the operator. Let's continue connecting the dots. If you look through the TCDS and the Bell maintenance information, you will not find reference to Garmin products. This means the aircraft has been altered from its original type design. Garmin elected to obtain a supplemental type certificate in its quest to properly alter the Bell 206 and 407 helicopters with their product. During this process, Garmin went through the same type of certification plan that Bell went through to obtain the type certificate. They produced drawings and performed tests that were all FAA approved. In the middle is the face sheet of the type certificate data sheet. On the right is the STC face sheet. As we look closely, both documents reference type certificate H2SW. The dots are now connected between type certification and properly altered condition. Sometimes we struggle with this idea of airworthiness. The choices are not always clear. We have all encountered an aircraft that was compliant. All the I's were dotted, all the T's were crossed, the paperwork was correct, yet there was an unsafe condition with the aircraft. We easily determine the aircraft is unairworthy because it simply is not safe to fly. It would not pass the family tests. I wouldn't put my family in there. We struggle, though, with the alternate scenario. In this scenario, the aircraft is in great shape. There are no leaks. Everything is tight. It's in great shape, but there's some form of lack of compliance or not exactly by the book. The aircraft is still unairworthy. Why? Because the FAA is not happy, right? Wrong answer. In the next couple of slides, I will try to present a different slant on the idea that aircraft that are not compliant lack an element of safety that we desire.
Socrates, philosophize with him.
All we are is dust in the wind, dude.
In order to make this point, we must think philosophically for a bit. When Bell certified the 206 and 407 helicopters, they performed many tests and captured thousands of data points. They determine how the helicopter performs, what it is capable of in all kinds of situations. They determine what can be described as the known values of the helicopter. Those known values are then incorporated into maintenance manuals, overhaul manuals, rotorcraft flight manuals, and a host of other documents. The operators then use that information to write training programs, AAIPs, and all sorts of other documents and programs we produce to provide safe operation. When we deviate from the type design of the helicopter, We enter the world of the unknown. From a philosophic perspective, not knowing has an element of danger. Some of the dangers of ignorance are: you cannot prepare, you cannot see what is coming, it limits your choices and power, and it amplifies consequences. As you can see, the dangers associated with ignorance can be subtle and perhaps slightly delayed, but the dangers associated are harmful just the same. To demonstrate the dangers associated with not knowing, I will use a real-world example. During certification, Bell helicopter test pilots performed thousands of auto rotations in all kinds of situations and atmospheric conditions. They took the information from those auto rotations and developed the height velocity diagram and the auto rotation chart. The height velocity diagram is then used to instruct pilots on how to fly the helicopter so as to avoid operations and flight regimes in which a successful auto rotation cannot be made. The auto rotation chart tells mechanics how to set the auto rotation speed, so the height velocity diagram has reliable information. So let's consider a scenario in which a pilot and mechanic are talking about the auto rotation speed of the helicopter. Because it is a little on the fast side, they decide to take a turn or two of the course thread clevis and yield an auto rotation speed of about 101%. The aircraft is in a condition for safe flight because the auto rotation speed has been verified, but the aircraft is out of compliance. The question is it safe, and is it airworthy? As we consult the auto rotation chart, we see the auto speed for the conditions should have been about 106%. We have now set it at 101%. The question is, will the aircraft make a successful auto in the very critical flight area on the HV diagram to the right? The answer is not sure. Now consider a situation in which the auto rotation speed has been adjusted in Kentucky in the winter. Next spring, the aircraft is selected for STC flight testing in Leadville, Colorado. Will the aircraft be able to successfully auto-rotate considering it is not adjusted in accordance with the chart and the atmospheric conditions have changed so drastically since the adjustment? The answer is you have no idea. And the question now is it safe? Is it airworthy? I do not want to belabor the point, but here are some words of wisdom. The paradigm, or the way we view things from a helicopter mechanic's perspective, is changing. We are accustomed to measuring things, tightening things, and sometimes conduct operations of gentle persuasion. These things will continue to be because helicopters are simply freaking cool like that. But the paradigm is changing, and it's growing. We now have to consider things like SD cards and software. We may be forced to make a choice between software version 7.0 or version 7.01. In reality, the difference between the two versions may seem insignificant, when in fact they differ so much that they could be critical to flight safety. So let's get back to connecting the dots. As previously shown, the STC certification references the type certificate datasheet number H2SW. The STC certificate calls out other documents to be used as well. One of them is the master drawing list. From the MDL, the document path will be further detailed. In the next slide, we will navigate to those documents as you will find them in the SharePoint. So now on the SharePoint, we want to look at the STC certificate and the MDL. All things good like that are accessed through the equipment list, so we're going to go there. And I want to go down to aircraft 192 because it's one of my favorites. So here we come to the equipment list, and I want to head down to the Garmin G500 system. So here we are. And so you'll notice that there are some levels of this, and one of them has a service bulletin 1585 employed. 192 Alpha Echo has that employed, and we'll talk about that a little more later. All of these hyperlinks are actually hyperlinked to the same information. So let's just go to the top one. We'll give you an overview of this, and then we'll show you the certificates. So you'll see here at the beginning is the origination, the STC, and we'll click into that and show you that. Here's the effectivity, of course. We're looking at 192, which is an L series helicopter. And then here are some documents that are applicable to all revisions. So if you have an aircraft, no matter which aircraft and no matter which level of software has been deployed, you're going to have some documents here that are applicable to all of them. If there's been a version 4.0, which is fairly old, most of you will not have that, but here are some documents in particular to that. The next one, version 5.01, there's a lot of those helicopters that are still that way, and those documents are applicable to that. And then the very latest, 7.01, and there are documents specific to that. So let's go up. We're going to look at the STC certificate, which is right here. And so you'll see that the STC number is SR02295LA. That's, if you look at the 337 for the helicopter, that's going to be referenced. Again, look at H2SW, so you see that goes back to the type certificate. And then you have Bell 206A, A1, B, L, L1, L3, L4, and 407. So if you have an L1 plus or an L3 plus, you're going to actually pretend like for a moment that it's still just an L1 because by serial number it really is. So then after you get to that point, you're going to see that there are documents being called out specifically, and it's the master drawing list. So that master drawing list is what really details the rest of the installation. The other document that you see referenced here will be the flight manual supplement. And that pretty much concludes an overview of the STC certificate, but I would highly recommend that you look at that. So let's go back, and the next thing we want to find is the master drawing list. So here's a master drawing list for one that's at reference version 4.0. So let's look at a master drawing list. It takes a bit. So here we have the master drawing list. It's FAA approved. That's very important to realize. So the things called out in this are FAA approved. Purpose, scope, document revision. Here are some definitions for you. So now if you have a Bell 206A, here's some things called out for that aircraft. It keeps going down. If you had a B model, which none of us do. If you had a straight L, there's the one for that. If you have an STC version on the L1, and we'll just pretend like that's it. You're going to see that all of these documents are important to the STC installation and will be referenced. Get the master drawing list, which is this document. It calls out that you must have an equipment list. It tells you if you've got an L1, so we're thinking about L1s, and we're going to have a revision number that's appropriate to an L1, and that would be revision 3. Okay, we have instructions for continued airworthiness, revision 1. Here's the document number. So you see there are several documents down here. Many of them are required, and some of them are optional. So that kind of concludes an overview of the master drawing list. As you can see, the master drawing list really calls out all the other documents that you'll be using. Now that we have seen the STC certificate and how the MDL relates, we will look into the equipment listing. The equipment listing is an inventory of required equipment and software per the STC. It should be noted that deviation from the equipment list voids the STC approval without an additional FAA approval backing that up. Now let's look at the equipment list. So we're going to go back to the same place. We're going to go back to the equipment list of the aircraft. We're going to scroll down. We're going to look for the equipment list that's applicable to version 4.0. And here it is. So let's open that. Again, it may take a minute. It didn't this time. So if you were to look at the master drawing list, it's going to reference this drawing number in revision 3. You could go back and connect those dots if you wished. It's got a table of contents that we're all familiar with. So when they tested this aircraft, they tested it with this equipment installed. And these are the LRUs. So it's got a choice of GDU 620. There were a couple. A GRS 77H attitude heading reference system, the GDC 74H, the GMU 44, the GTP 59. Calls out optional equipment that you could use. And now it calls out hardware, or I'm sorry, software. So the software is very important to the way the aircraft functions. Some software versions that are available are for fixed wings, and they operate very differently. And so, because we're installing this to a helicopter under an STC, they've tested the system with all of this software. So this is a software that is applicable. So if you go into the configuration settings, you'll be able to see that these versions are in there, and you'll be able to verify those. It's pretty important to verify those if you're doing a system install, or if something happens and you've got to do a full software upgrade. So here are database and enablement cards that you might use. Reference prerequisite installed equipment. So I'm going to get a question now that we're looking at this. Let's go back up here. And let's say that it was previously installed with a GTP 59 outside air temperature, but we wanted to install a different one made by Garmin because they make a few. And we make a deviation. Would we know then if this system works correctly? And the answer is we would not know that. Again, the element of unknown. So if the outside air temperature it might work, might not work correctly, and it's important to know that a lot of calculations are made upon accurate OAT. So you would not be allowed to deviate from that outside air temperature probe. And the same might go for a piece of software. Let's say we had a different version. If we had a version 2.2, it would again deviate, and we wouldn't be certain that the unit would function properly and be safe for a helicopter. So this is just the next level in. This kind of shows you exactly what has to be there for it to be correct. Next up in the documentation lineup is the instructions for continued airworthiness. The ICA is the maintenance manual for the system. It's also the inspection manual and parts manual for the system. This is the manual you will use when an LRU requires replacement. This manual will also assist you with troubleshooting help. Next up in the lineup is the instructions for continued airworthiness. So let's go look at that document. It's an important one to you. So you're going to go down to your appropriate software version. It'll call out a specific ICA. So for 4.0, it's got this one. We're going to open that up. And it's typical of other ICAs that you might see out there. It has all the same elements. All the same elements. So I'm just going to scroll down and let you look at that. And I may stop and comment on that a little bit. Shows where the descriptions are. Now you might note that the descriptions and the locations are slightly different. That's why we have an installation drawing. I'll show you that later. This shows the periodic maintenance instructions. So every 5 years, the Ahurst unit has this procedure that must be done. Every 12 calendar months, these items need to be done to the system. Now you get up to troubleshooting, and so you'll have very specific faults that may happen. This is very inclusive, and so it will show a cause and a solution. So when a pilot reports something, you can go to this and kind of know where to go to that after that. Number of alerts that happen on the GDU 620. You'll see these alerts. Pilots will say, "Hey, I've got a cow lost alert coming up," and then you'll see the treatment of that. Contact Garmin technical support. Fan 2 fail, and it gives you a cause and a solution. There's a lot of those. Removal and installation. These are very important. So let's say the GDU 620, the display failed. You would go here. It would tell you how to remove and install, and then it gives you specific actions. If it was an original to be reinstalled, then you do one thing. That means you basically gained access. You took the unit out and you're putting it right back in. Or if you have a new repaired or exchange unit, and then it's going to tell you some other actions that you must do. So there's a number of LRUs in the system it tells you. So here's some calibration that you have to do, and there's reasons why you have to do that. It's listed here as well. Return to service. When you return a Garmin 500 system to service, you'll need to do some checks. There are, just like a hard landing inspection on an aircraft, you have a post-lightning strike, you have special inspections on the system that you need to be dealing with. And that concludes the ICA. As you can see, it's very much like other ICAs, just a little more inclusive, a lot more stuff. Next up in the documentation lineup is the installation manual. This was the manual used to detail how this system was initially installed. The installation manual is still relevant, though, to mechanics after the initial installation. The installation manual contains software loading instructions, advanced configuration settings, and will also provide advanced troubleshooting help. The next manual we want to look at is the G500 installation manual. It's an enormous manual, but it contains a lot of information that you will need. So let's go there. So here's the installation manual. Chapter 5, System Configuration and Checkout, will be very important to you. As you can see, it is an absolutely enormous manual. And I'm not going to take the time to go through all of it. So let's just go to Chapter 5. I'm going to reach that. So this is the beginning of Chapter 5. It shows the post-installation power check, several other things. This is where you're going to find how to load software. You'll be referenced to here. You're going to need an unlock card. It tells you exactly how to do that. We also issue some documents to help you with that. All right. That's That's about all I'm going to do with that manual. You can see it is absolutely huge. Chapter 5 will be the most important part of that for you. You might find other things in there that you might find helpful. So if you're having an advanced troubleshooting problem, you will be going to the installation manual. The next document we will review is the installation drawing. This drawing details how the units were installed into the AEL aircraft. This is an improved document and details the differences in the AEL installation. The AEL installation differs from the STC installation instructions and is the improved basis for the properly altered condition. The installation drawing contains the interconnect diagram, which will be needed during advanced troubleshooting. Next up, a very important document for everybody out there. It's the G500 avionics system installation. And you'll realize, if you look at this, it is an AEL document. So when AEL put the Garmin G500 system into the helicopters, they deviated a little bit from the plan. And so we got an FAA approved document referencing back to this drawing. And those situations that we've done, the changes, the deviations, have all been vetted by DER and are FAA approved. So let's go into that. This will be used very specifically if you have an issue with a certificate. An issue with the unit. All right. As with any drawing, there's a lot of notes called out. You'll see those notes called out, and this is where they are located at the very beginning. Here are the locations of the units. This is a view looking down. This is a view from the side. Everything's called out with water lines, flight stations. Location of the GDU 620. That's how it's installed to the instrument panel. This is showing the air data computer location. It's up front because it hooks into the pedostatic system. It's very, very convenient location for that. The Ahers needs to be level toward the center of the aircraft, so it's back above the baggage compartment, as you can see. Magnetometer needs to be as far away from a lot of electricity as it can be. This was not the primary location, but a very good location, so this is an alternate that Garmin allowed for the magnetometer. The OAT probe, you can see that is on the bottom of the aircraft. Very specific instructions on how to route the honeycomb material, how to make a stiffener plate, and where to edge fill. This is continued. Notice it gets detailed down enough even on how to do a tie wrap for strain relief. It's pretty important. Now we get into the meat and potatoes, which is the wiring diagram. So let's say you felt like you had a ground problem. This would be where you would go find the wire number, the pin number from the unit. So this is the 620. It has let's say we wanted to look at the circuit breaker. We wanted to know what the power lines were for that. They're called out specifically there. We realize it's a 5 amp breaker. It should have a label on it that says PFD. The interconnect diagram, and then here is the legend on how to read that interconnect diagram. If you'll notice, there are a lot of shielded wiring in that system and terminations to ground. Here's the interface from the 620 to the autopilot that's resident in all our machines. And that concludes this document. Interconnect diagram and physical locations and very specific information on how to install hard points for some of the items. That's good information for you. Remember to read all the notes when they're called. The Rotorcraft Flight Manual Supplement describes how the pilot will use the system. It also describes the failure modes of the units and will describe the appropriate pilot actions in the event of a failure. The mechanic will need to be familiar with the RFMS as a basis for effective communication with the pilot when there is an issue with the system. The RFMS contains a general description of all functions. It's also good information for the mechanic. You may not think you need to reference the Rotorcraft Flight Manual Supplement often, but it will be important for you. Rotorcraft Flight Manual Supplements are software version dependent because the units may act a little differently. So we will look at this one, version 4.0. We'll go down to the Flight Manual Supplements where they are. So you'll notice if you got an L1, L3, or L4, there will be a different Flight Manual Supplement that would be called out on the equipment list that way. So let's look at the L1 RFMS. And they're very similar, don't get me wrong. So this is a typical where you would download this, print it, put the registration serial number on it, revision status of that document, and the general information. So it's calling out again software because the pilot can look at the software version. It's important for the pilot to know that the latest software versions are there. Here's some database things, stuff that pilots truly care about. You'll see this HSVT. We do not have synthetic vision. So you'll see some things called out that we don't have. So here are the equipment requirements. We have an MEL that calls out for stuff on this, but people operating Part 91 need to understand that they need to have one of these installed, and to be flying VFR. What's really required for dispatch is a standby altimeter, a standby airspeed, a magnetic compass. Basically calls out the instruments that have to be there in order to fly the aircraft. Doesn't necessarily mean it's right. Normal procedures, it tells the pilot how to interact with the system. It takes a great deal of training to do that, repetition. So where you might be called into are warnings, conditions, advisories. So you'll see a pilot may come in and say, hey, I've got an enunciation for attitude fail. And the pilot action is use visual references, basically fly the aircraft and land. And the cause, display system is not receiving AHRS information. It's good information for you as well, but you need to know what the pilot is required to do. He's going to go ahead and fly the aircraft and ride it up and get back. A lot of warnings. And there are red warnings that are more important for the pilot, so they call out different actions. And performance data, and then this general information basically is an overview, system overview. This also contains really good information for the mechanic who's wanting to get a little more information about the functions of the unit. Very simplified system diagram at the end, and then there'll always be definitions that you're not familiar with, probably as a mechanic. They may be saying TAS, TIS, VFR, things that you may or may not have heard before, and this is a good place to find what that means to you so that you can, again, effectively communicate with the pilot. This is the basis for that. You need to know what is contained inside that manual. So if you would, look it over. We all know that everything changes. Garmin issues service bulletins when changes are required or as an option to the operator. Service bulletins detail changes within the system. Service bulletins within the Garmin system are issued to detail changes in documentation that affect changes to the system. A typical service bulletin will change the MDL, which will in turn change other documents as well. Let's read through a service bulletin in the next slide. So with service bulletins, it does get a little bit tricky. So it's important to slow down and figure out what the service bulletin actually says. So let's go back down to the system. Remember we said we were on flying helicopter 192 Alpha Echo. So we see here that we got SB 1585. It's employed on that helicopter. So we want to read through that. That in particular, that service bulletin is going to change several things. So let's just go look at it. So that service bulletin was issued to authorize version 7.01 software upgrade. So we open this up, and you see it's typical, Garmin Aviation Service Centers. That's us, actually, AirEvac. We are a service center. It's dated. It references the STC that's important to us, and then the subject. And this one shows that new interfaces and upgrades provided by the GD620 software version 7.01. So if you walked up to an aircraft and it was at version 5.01 and you wanted to update it to 7.01, you would use this service bulletin to guide you through that. So we're talking about purposes. It tells you exactly what the upgrade really brought for us. And for us, it brought a lot of multifunction display that we needed, primarily in the form of the ability to display the ADS-B. So when you may see this if you're having to upgrade the ADS-B. Document considerations. So again, this is really, if you look at this and remember back to the MDL, you're going to see a new basic rotorcraft flight manual supplement, and you're going to see new ICAs. It calls out new documents. It calls out new references. So you're going to see new references, and you're going to see new revision numbers. So here is the modification instruction. It's going to point you then to another service bulletin, help you with the software update. Going to tell you to make sure the software versions listed display the equipment listing, revision 5. So there may be a new revision to the equipment listing. Update and complete configuration checkout log. So there's something that you would get in the installation manual. Again, the installation manual is important and continues to be important to the mechanic. So if there was a VSI rate of climb and some of the there was a placard posted on some of the aircraft, if you're putting this software update in there, they're asking you to remove the aircraft. So it actually changes the configuration of the aircraft. So you can see that service bulletins do quite a bit of updating. They have to be read very closely. Provide a completed RFMS and ICA documentation. So there is an updated RFMS, and that is pretty much the extent of a service bulletin. So it's 4 pages long. This one's 4 pages long, but it really, in a sense, changes volumes of information. And again, follow these line by line and do exactly what they say, because there's a lot of details and a lot of changes that have to be done when a service bulletin is employed. It's good information. Please read over them very carefully before you do any work. I hope this presentation of the Garmin documentation was beneficial. As mentioned, all the Garmin installations in recent years follow the same schema, so this information should be consistent with all the other Garmin installations. We hope the review of the term airworthiness helps as well. Fly safe, everyone.